Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about how to multiply binomials. We're in the Common Core standard of the number system, and we're going to be finding out how to work with and solve various degrees of polynomials and working with right triangles later on. All right, so we're going to learn how to factor and expand expressions and find x-intercepts today. All right, when we're looking at multiplying binomials, what ends up happening is we are able to find and solve so many more math equations than we've ever been able to do in the past. Things like, hey, I hit a ball at a certain angle, at a certain speed, and bam, I know where it's going to land. I can graph it, I can tell you how far, how high it's going to go, all that, all just because of binomials. Pretty cool, huh? We're able to use math and baseball. Never thought you'd be able to put the two together, huh? All right, so the equation for hitting a ball is this. It's y equals x times the quantity of 1 minus 2 thousandths x. All right, so if you were to say, hey, I want to know where a ball is going to land at a particular height, I say, hey, I hit the ball at x, and then it gives me the height in y. Pretty cool, huh? All right, well, let's work with that and let's talk a little bit more about it, okay? Well, in the past, we've looked at the distributive property, and now we're going to use it with variables. And when we use the distributive property with variables, we can talk about expanding equations and then going the opposite of the distributive property and factoring expressions, okay? So when we factor something, it's the opposite of the distributive property, and it's similar to taking each of the terms out. So let's look at this. We're going to factor this first one. We have x squared plus 2x. Well, what's similar here that's also in here? Well, you have essentially two x's there, and then you have x plus x here. So you can pull out an x from there and an x from there. So then it's x times the quantity of x plus 2. We have just factored this expression. Now, what's common here? You have a 4 and a 2. So the common factor there is a 2. And then the common factor, you have 3 x's and 2 x's. The common factor between these two guys is 2 x's. So I would take x squared out, and then I have the 2, and then what's left over? I took out a 2x squared, so basically I have a 2x there, and a 1. It doesn't go away to 0, it goes down to 1, okay? So basically I have divided this by 2x squared, and you get 1. Not that difficult, huh? You're really just doing the opposite of a distributive property. And the way you figure out whether it's the same equation after you multiply is just take the x, multiply by the x, and you get x squared. Take the x, multiply by the 2, and you get 2x. Try it here. 2x squared times 2x gives me 4x cubed, and then 2x squared plus 1 is 2x squared. Okay? So in order to check your work, definitely go backwards. So let's expand this guy. Let's do the opposite of factoring, and let's expand it. So take the x, multiply it by the 3x, and then take the x and multiply it by the 2. Okay, we multiply it by both of those guys, and what do we get? 3x squared minus 2x. All right, let's try this one. We're going to take negative 3x squared, and we're going to multiply it by negative 9x squared, and then the 2x. So what you're doing is taking this, multiplying those two together, and then taking this and multiplying those two together. So the negative 3 times the negative 9 becomes positive 27, and then the x squared times the x squared, add the exponents and get x to the 4th. Try this guy on your own. All right, you end up with minus 6x cubed? You should have. All right. So now let's go backwards. Let's do the opposite of the distributive property and factor. What's common here that's also common here? Notice we can take an x out of there and an x out of there. And also notice as you've got a negative there and a minus there. So I can actually pull out that negative to make it look a little bit simpler. I pull those two negatives out and bam, I get this. Negative x times the quantity of x plus 5. If I want to figure out and see if I've got the same thing that I started with, I take this and I multiply by that, take this and multiply by that. I expand it out to see if I got the original equation. And if I did, then I'm good to go. All right. Why don't you try to do this one? What can you pull out from the first one that you can also pull out from the second one? You got a negative there and a minus there, so you can pull that out. You got a 4 and an 8. Well, if you factor out a 4 there, that can come out. You factor out a 4 there, you're left with a 2. How many x's are in common? Just have one x there. So you should end up with something like this. All right. Now let's talk about binomials. Because once we've factored, we can now find the x-intercepts very easily. Now what I mean by x-intercepts is where the line hits the x-axis. Just like in the past when we've done the y-axis with the y-intercepts, now we're going to do the x-intercepts. The start and the stop of the equation. So if you think back to the baseball, throwing the baseball, the first x-intercept would be throwing the ball, and the second x-intercept would be where the ball lands. All right. Well, in an expression, if we have two terms, it's considered a binomial, okay? It's an expression with two monomials, and a monomial is one term, such as 2 or negative 4x or 5x squared, that kind of thing, okay? Binomial has two of those guys. All right, so let's find the x-intercepts here. We've got y equals x times the quantity of 3x minus 2. Write that down, and let's try and find where this line, this curved line, hits the x-axis. Okay? Well, if you think about it, the x-intercept means that y has to be 0, right? Y has to equal 0. Just like before, when the y-intercept, the x equals 0, now the x-intercept, the y equals 0. So let's do it. So, got to have this equation, 0 equals x times the quantity of 3x minus 2. So if you think about it, either x has to be 0, this guy has to be 0, or this guy has to be 0, right? In order for this to equal 0, either this has to be 0 because you multiply 0 times whatever is over here and you get 0, or this part here has to be 0 because then you multiply it by x, whatever x would be, and then it would give you 0. So those are our two options. So the first option is super easy because x would be 0. Well, that's one option. The other option is solving for x here and telling me what x would be, okay? All right, solve for x. We get x equals 2/3, and we get x equals 0. So this curved line hits the x-axis at 0 and at 2/3. All right, let's do this one. Now notice this one doesn't look like the one we just did. We have to do what first? Well, if you said factor, you're on the right track. Let's do it. Let's factor x squared minus 5x. This becomes x times the quantity of x minus 5. All right. Remember what y has to equal? Okay, so it has to equal 0. So then either this equals 0 or this equals 0. X minus 5 equals 0, which is x equals 5. Okay, so those are my two options. Throw the ball at 0, you get it back at 5. Okay, why don't you do these on your own? Work with expanding them and then work with factoring them. All right, now I want you to find the x and y-intercepts for both of these. Now the y-intercepts, remember how to find the y-intercepts? X has to be 0. Okay, y-intercepts, x has to be 0. X-intercepts, y has to be 0. All right, here are your answers. All right, how you doing? You able to factor now? Able to expand expressions and find x-intercepts with these binomials? I bet you are. Not too difficult, huh? Well, this was Matt with MathsMath.com as we talked about multiplying binomials and hitting baseballs with the power of that math bat. All right. Well, this was Matt, and check us out on Facebook at Solving Maths Problems or on Twitter at Maths Math, and enjoy math and baseball.